Okay, everyone. So I'm going to present today a talk on generative AI applications in the serverless world. I'm Todea. I'm a site reliability engineer at Elastic. And I'm going to brief you a bit on why I wanted to give this talk. So like we all know, generative AI is a very hot topic at the moment. It has been for the last couple of years or so. I wanted to, when I started to have this idea about creating this talk, I wanted to give a fresh, let's say, new outlook on generative AI, but from a DevOps point of view, from a site reliability point of view. I'm not a machine learning engineer, I'm not a data scientist, but although generative AI is impacting the DevOps world as we see it progressively every day. So the agenda today is going to be focused on me revisiting some of the Gen AI concepts and technologies that are relevant with the Gen AI applications I'm going to be speaking about. I'm going to deep dive into a use case, and then I'm going to explain the applications that intersect with the DevOps world. So let's get to it. There are around top 5 trends for search and AI in 2024. I just wanted to check on this to give a bit of a context to generative AI, machine learning, and LLMs. So we are very accustomed to be seeing the list of links when we want to get results on a web browser, when we want to get, when we start searching on a web browser. And this actually will change a lot starting with 2024 and onwards, of course. So users will be more, let's say, expectative on those queries, like natural language queries, and they will be expecting like a very interactive conversational experience with a prescriptive answer. Then second, we'll be seeing a lot more the discussions around data safety and privacy continuing in 2024 and onwards. Basically, because there are lots of, let's say, discussions around the legal implications, intellectual property for training models, the organizational data safekeeping practices and user protection, etc. So this is something that we'll be seeing a lot moving onwards. Then the third trend will be consistent with the proper context for generative AI. Due to the challenges of generative AI, like, for instance, hallucinations or outdated training data, and right now there is a bit of urgency, right, a bit of focus to guide generative AI within the, let's say, mechanisms such as retrieval augmented generation that provide LLMs with critical domain-specific context from proprietary data. And the fourth trend will be seeing a lot of, new wave of large language models. We'll be seeing a lot of new LLMs this year, and this trend will be continuing moving forward. So these data models will become even more efficient, more adapted to all kinds of business purposes. And fifth, but not the least, the developers will be requiring a lot more, let's say, upskilling in the area of AI and generative AI and LLMs. So we'll be seeing that a lot, not just on a foundational level, but obviously even more complex and advanced than that. So just to have a bit of refreshers, let's say, into where Gen AI is positioned in relation to machine learning and LLMs. Basically, Gen AI is a subspecies of machine learning, right? That is focused on AI algorithms that are designed to create high quality content, like, for instance, text, image, and audio. And we'll be seeing such applications like chatbots, text, image, or music generators. For instance, at their own turn, Gen AI obviously have their own subsets of LLMs. Now, these are focused more, let's say, like algorithms that can generate text. For example, like translation, writing, answering questions. A very important concept in machine learning is the concept of transformer, which is a neural network that learns context and meaning by tracking relationships in sequential data, like the words in the sentence. This is very important in generative AI because it will be linked to the applications that I'll be mentioning later. So what can transformers do? Basically, a lot of things. We have been using them. You have been using them in a lot of use cases. I'm pretty sure they can, do like question answering, sentiment analysis. They can extract information. They can capture an image. They could do object recognition. They could do they could follow instructions. Basically, even when we interact with a search engine, we are using actually a transformer, or when we want to prevent fraud or improve healthcare, the machine learning transformer is there. So basically, they're very well spread in that sense. I wanted to discuss a bit on the transformer architecture, as it will be relevant for the applications later on. The transformer architecture is focused on two layers of encoder layer and the decoder layer. And these are the encoder layer and the decoder layer are pointing to the self-attention mechanism. Whereas the multi-headed attention is a very important concept as well. Why? Because the transformer architecture basically is using natural language processing, like I said, like translation, text generation, sentiment analysis. So it will be getting their input and generating output. We'll be getting a lot into that later on into the architecture. The generative AI architecture is focused more on the content generation. So depending on the data that has been fed in the pre-training or in the training phase, like images, documents, or audio, then depending on the query or on the prompt, it will generate a new image or something similar to what has been fed during the training, or a document or an audio file. It works with the nearest neighbor mechanism that actually points to the results based on the vector representation. This is something really interesting, and we'll be seeing both generative AI and transformer architecture blended, used in the applications later on. So, like we all have been using ChatGPT and probably other applications like this. When we start interacting with a generative AI mechanism, basically we are querying it. We are using a prompt. We are asking a question, and under the hood, let's say the Gen AI or the LLMs are looking inside that corpus of data. That data that was fed in the training phase. It will search for the information. It will search for relevant, let's say, information, and will provide the result. Later on, we keep further interactions with the LLM. So we keep asking, we keep refining basically some of our questions, our prompts. And in return, the mechanism will do exactly this as well. So it will redefine as well. Sorry, we'll reuse. We'll try to be better, at providing answers. And that basically it's gonna become very important in the way it operates. As I mentioned before, the concept or the mechanism of retrieval augmented generation is important once we start discussing proprietary data sources. So a RAG starts with an input query. The retrieval model grabs the relevant information from databases or external sources. Then the retrieved information is converted into vectors, into a high-dimensional space, and then they are stored into a vector database. The retrieval model ranks then the retrieved information based on its relevance to the input query. The documents with the highest scores will get selected for further processing. So basically, this is what happens when we are querying it, when we are querying a Gen AI mechanism, and what happens under the hood. a new way, let's say, or a different way of boosting the performance of RAG is, for instance, with ELSER. This is, let's say, a use case at Elastic. ELSER is basically natural language processing model for English semantic search that uses sparse vectors. So it prioritizes intent and contextual meaning over literal term matching and is optimized for English documents and queries. So this is very interesting because once we use ELSER with RAG, then we see improved performance of RAG itself. And will give, let's say, even more relevant, will provide a relevant context for search results without requiring fine-tuning. So that's also something to bear in mind when you're using RAG. So as I mentioned before, I'm on SRE. I'm a self-reliability engineer, and the majority of my time I spent investigating either alerts, queries, logs, errors, etc. And what I think when I'm defining my job description as an SRE is that I'm pretty much like a detective. So I'm pretty much like in the shoes of Sherlock Holmes, trying to find out where's the problem. So I'm performing my investigation, and I'm using a lot of research as well. And then when I'm finding, let's say, the root cause, or let's say the mechanism, I'm trying to explain why this thing happened. And generative AI has proven to be quite the useful mechanism that can help me in this investigation, that can accompany me in this investigation. And one very important tool, or tools in general, are the observability tools, in specific observability AI assistants. So these are based on generative AI and also on transformer architecture. So behind, under the hood, behind the scenes, we are seeing the transformer architecture and also the generative AI architecture working together. So there is about, what happens there is we get image generation, we get text generation, but we also are looking at natural language processing. So both of them are kind of meshed together. And depending on the data we have fed in the training phase, we can get a lot of, let's say, support, a lot of assistance in that regard. So you can have obviously different types of data, whatever you want to use. In my case, or in our case as DevOps engineers, we can find it really, really helpful with data such as metrics, logs, SLOs, synthetic or real user monitoring, application performance. So a lot, you can, have different use cases in technical support as well, etc. On another side, you can have business data like sales, marketing, business operations, logistics, and production. So in a nutshell, this what happens with an observability AI assistant and how it works, in relation with the data. So here we're gonna watch just a short demo of the observability stack working together with an OpenTelemetry application that will also be integrated with the Elastic AI assistant. So we're gonna see basically a few things that are integrated together. So let's take a look of how this. So here, basically, I integrated my open demo application with the SLOs. That will provide me some information when these SLOs are going down or are being violated. I can check, in the case of violation of these SLOs, the performance of my service. So I can look, for example, on the failed events, on the errors. I could check more on the metadata side. I could look at different labels that I've been using for my service. So basically let's say a lot of substacks here, traces, and so on. And then if I want to get even more, let's say, in-depth with the error, I can even go ahead, click on the Elastic AI assistant, and to get right from the user interface more information about that. I'm going to get a breakdown of the trace. I'm going to get like possible causes of the error. I'm going to get a link to the runbook that I've been fed, or the GitHub issue. And then I could even ask further questions live on the AI assistant. So is there a runbook, for example? Yes, there is a runbook. You can see the following steps. And obviously, if you want to go directly to that runbook webpage, you can click on the link as well, and it will open up the runbook as well, as we see in the example in the demo. And here in the runbook, yeah, we see whatever we have done here as steps. Then we can integrate our application with different connectors. We have a lot to choose from. You can pick your poison, how they say. If you want to work with Oracle, Azure, Blob, Dropbox, etc. So there is a lot of lists here that you can link it. So this is, in a nutshell, very short, how OpenTelemetry demo application works with observability tools and with Elastic AI Assistant. So I mentioned before that you could go further in depth with alert analysis. You could get, useful information on alert list. When did they last executed, more information on the description, etc. You can go and ask, like, okay, right now that I get this error and it's active, how can I troubleshoot it? And you can get a list of troubleshooting steps that will be very helpful, as a DevOps engineer. On the sides of SLOs, you can, analyze the current states of an SLO that you just provided. Or you can even ask theoretical questions. Okay, how do I create a percentile 99 SLO? We'll give you all the information that you need. As well, on the serverless architecture, how is it possible to create such an SLO? So quite a few steps there right out of the box. On the APM side, you can use it to get more information on the transactions, on the errors, even on the latency. So you'll get that image generation part that I've been mentioning from the Gen AI side. And it's integrated nicely as well with synthetics, with monitoring. And here you could see, like, when your monitors were last active, if they are down, etc. So a lot of use cases, a lot of applications in that sense. The AI system acts like an assistant to the DevOps engineer or the SRE, whoever is there, and needs basically support whenever is on call, or just basically doing its investigation on a daily basis. So right now, I'm just going to move back, let's say, to a theory a bit. So behind the scenes, under the hood, the Elastic AI Assistant works with a custom prompt, like we've seen, with SRE, which is the Elasticsearch relevance engine, and with Amazon Bedrock Anthropic Cloud V2 model, which is very helpful in this regard for this specific use case as an LLM, basically because why you can edit, rewrite, summarize, classify, extract structured data, is also designed to reduce brand risk. So it's helpful in regards, let's say, for security question when you want to troubleshoot more security issues, and can read through prolonged log records. And yeah, it's quite helpful in that regard as well. If you want to take a bit a look in more depth on Elasticsearch LLMs, there is a repo called Elasticsearch Labs that is there for you to test it out. Basically, you can go there and create sample apps. You can use Elasticsearch as a vector database to store embeddings, and you can build actually use cases like for retrieval augmented generation, summarization, answering. And it works a lot, works with different projects like OpenAI, Hugging Face, LangChain. It's very helpful to get started with this. As I mentioned earlier, AI assistants are, let's say, just a part of the use cases of generative AI. And these work very well on the Serverless platform as well. So I gather here just a few benefits, let's say, that could be helpful, that could be, advocating the AI assistants on serverless. And some of these are, for example, function as a service, which exactly what will happen is that an AI assistant will be deployed as a function. And these functions will be short-lived and stateless and will be triggered by events such as user requests. Then one benefit of AI assistant on serverless is scalability. So whenever multiple users will interact with the AI assistant simultaneously, the cloud provider dynamically will allocate resources to handle the increased workload. That's also an important part. Also, the cost effectiveness, because the serverless architecture follows a pay-per-use pricing model. You can just pay for as much as you use. As long as you have specific function execution, you pay only for what you have used, and then you can have it integrated with other services. Like, for example, you can utilize it with cloud-based databases for storing user preferences or external APIs for accessing additional information. And not the least, you can use it in an event-driven architecture because serverless architectures are just inherently event-driven. So meaning that these functions are triggered by various events such as HTTP requests, database changes, or scheduled events. So moving forward, obviously AI assistants are just one use case, but there are lots of things that you can do besides this. So you can use personalization and recommendation systems on serverless as well. You can use image and video synthesis. For example, from the angle of generative adversarial networks, you can deploy this to synthesize realistic images and videos. These are very used, let's say, in the creative world from artists. You can use data augmentation, for example, to augment data sets for training machine learning models on serverless as well. For example, as well for content generation. You can generate various forms like we've seen so far, using it all with a serverless architecture. So these are just a few examples. Obviously, right now we'll be seeing a lot of these moving forward. So where we at the moment? So in the case that are developers using Gen AI in general? Do they have, let's say, applications for this? Well, based on a survey, Elastic and Dimensional Research actually performed, it seems that 87% of developers are using already generative AI, so they have applications, but only 11% actually integrated it with production environments. And why? Basically, we are seeing the results on the slides. So some of them just very important challenges regard preparing your private data to use with Gen AI. So this is links to the RAG mechanism we have seen earlier. So it's not so easy to focus, or let's say, train your private data to use with Gen AI. There's a lot of work involved there. Then second, you need to be upskilling your technical teams. So it's let's say a brand new or sort of brand new technology, but you need a lot of developers to start training on this new technology. So that takes time. Then you need to train the proprietary model. You need to integrate it with LLMs or Gen AI stack, and not least, you need to think about those infrastructure costs. Like we've seen, serverless is just one example to cut down on those infrastructure costs. But in general, that's also a very important aspect to take care of. What's are, let's say, the top considerations when selecting a vector search engine? Well, there are many challenges or considerations here as well. You need to think about reliability, about the cost, about operational simplicity, about the ease of use for developers, and query latency. These are all something that we have been facing as DevOps engineers, I'm pretty sure, in our experience. So it's very important to take care of this as well. So I want to summarize a bit this talk. I said at the beginning that, I wanted to provide like a fresh outlook on generative AI. What I wanted to take here, or what I want you to take from here from this talk, is that once you decide on the use case of generative AI in your organization, you also need to communicate a lot more, let's say, intensively with your machine learning teams, with your data scientists, because you need to correlate all these challenges together. So you as a DevOps engineer or as an SRE, you'll be bringing a lot of value to the table. You'll know, for example, how to do a troubleshoot, where to look, how you could speed up a few things on how you can cut costs, how you can speed up, let's say, the performance of applications. So you need to constantly provide feedback to your machine learning teams, and you need to work together basically to improve that use case. Whether it's an AI assistant, whether you'll be using a chat box, whether you'll be using, I don't know, different other applications that best serves for your organization. Here I also presented a list of resources that will help you start, or if you want to check the OpenTelemetry demo application, the Elasticsearch Labs, please give it a go. Also, this is you have here an example of the blog for Elastic Search Labs, the repo, and obviously some research like vector search and how-tos integration with Lucene. Give them a go. Thank you very much for your attention so far. Please don't forget to add your feedback. And if you have any questions, I'll be looking at the chat right now. Thank you so much.